So I think I will give a good crack on this math method exam 2 recently for the 2024 NHT paper 2. And you have 15 minutes for reading and 2 hours for writing, but I'm not going to use the reading time. Section A, you have 20 multi-choice questions, and section B, 5 extended response questions. First one, the period and range for the function. So for any sine and a cosine function, the period is 2 pi over n, which is 2, equals 2 pi. For the range, you probably need to assume this is your amplitude, √3. The vertical translation is negative √3. So I'm going to use c minus a and c plus a. That gives negative √3 minus √3 and negative √3 plus √3. Eventually, it's negative 2 √3 and 0. Okay? So I'm going to choose C. Now, for two independent events, A and B, it is known that probability A is 0.6 and probability A union B is 0.92. So we would like to find probability B. So if I quote this formula, probability of A union B equals to probability of A plus probability B, subtracting probability A intersecting B. Just notice that this thing is also, probability of A times probability of B because of the phrase independent events. Okay? And pretty much you can just replicate whatever you had here. So for example, this bit can be replaced by 0.92. And this place, we will sub in the value of probability A. Also, you can sub in the probability value A here. All right. Pretty much this is giving you, let's say, 0.32, because you are taking away 0.6 from right-hand side, equals to 0.4 probability B. If you simplify these two terms, which means your probability B is only possible to be 0.8, and that is 4 over 5, okay? Option A. Question 3. The positive real numbers A, B, C satisfy the equation log 5A. Well, I wish they had a brackets here. Therefore, it must be true that, okay, so if I combine the left-hand side, I should be able to get log 5, stick A and B together as your arguments. And also, 2 log 5c is like log 5c squared. You bring the power into the argument, so you can equate the arguments. And all options are transposing A, making A the subject. So I will have c squared divided by B. Option D. Question 4. A straight line passes through the positive x-intercept of the curve of the cubic y equals to x cubed minus x squared minus 2x, and also through its point of inflection. So we would like to find a gradient of this line. Well, I think this is a good place to apply some technology use. So let's see. Now, say I plot the graph here, x to the power 3 minus x squared minus 2x. So pretty much this is a graph, and the question mentioned the positive x-intercept. So I suppose this is 1 point, 2, 0. And also, if you notice, the inflection point can be found graphically via your CAS calculator, which means, okay, this is 0.3 recurring. I suspect the exact value for the point of inflection is 1/3 at x equals to 1/3. So the question wants to find the gradient of the line segment between this point and this x-intercept. Therefore, what I'm going to do is I will just select a split screen. And then notice that I've defined or plotted f1 of x. To figure out the gradient, I'm just using a fraction, 0 minus f1 of 1/3, and a 2 minus 1/3, rise over run. And that gives me 4/9, okay? 4/9. So therefore, option A should be the correct answer for the gradient of the curve. Now let's move on and look at, the rest of the multi-choice questions. Question 5, when a biased coin is tossed, the probability of the coin landing on the head is 0.25. The coin is tossed 10 times, and the number of heads is recorded. The probability that exactly X heads are recorded. Now, this is just telling you 10 choose X times probability of success, which is 0.25 to the power X. And 1 minus P is 0.75 to the power of the rest, 10 minus X. So therefore, when you are browsing through the options, there is only one correct option, which is option B. Pretty much, this is a binomial distribution, okay? Binomial random variable. Okay, question 6. The graph of y equals to tangent ax has an asymptote with equation x equals to pi over 6. So I would like to find a possible value of a. So what you can do here is try to plot all the options. And now, if you recognize the asymptotes, let's say for y equals to tangent ax, the middle two asymptotes will be plus or minus pi over 2a, okay? So let's say if you choose 4, then the bottom here will be 8, impossible. And when you choose 6, you will get like a 12, well, questionable. If you get a 9 here, well, we better see the other asymptotes, because what I'm saying here is just the middle two asymptotes for the tangent graph. So a good idea is to use your technology. Now, if I'm plotting tangent, let's say 6x, so many branches, I wouldn't be able to see that. But what I can do is I can adjust the window settings. I don't really care about the y values because the range of tangent is just real numbers. But I'm going to do minus pi over 6, pi over 6. And how about I'm using pi over 12? So now you can see the pi over 6 becomes an x-intercept of this graph, which is not a vertical asymptote. So option B is no good. Therefore, I'm going to try another one. Let's see if I try option C with a equals to 9. Perfect. Because you can see the graph is approaching to pi over 6 at this branch, at this end, okay? So therefore, I would say option C is the correct answer. Okay? And we can now move on to question 7. Question 7 says the function with domain all real numbers, f of x is a times cosine b minus 1x plus b, has a period of pi over 3 and a maximum value of 10. So b is greater than 0. Therefore, if I'm looking at a cosine function, I've got 2 pi divided by m. In this case, my m value is b minus 1. And that equals to pi over 3. So I should be able to get a b minus 1 equals to 6. If I cancel out the pi here and cross multiply, Therefore, my b value can only be 7 because b is greater than 0. This is a reasonable answer. And a b is my vertical translation. A maximum could be possibly given by a plus b equals to 10. Therefore, a plus 7 equals to 10. And a must be 3. Okay? The question actually wants us to find the minimum value, say, if I've got a cosine function like this. This is a maximum 10. This is a middle line 7. The amplitude is 3, so the minimum must be 4. Option B must be the minimum value of the function. Okay? So far, the 7 questions are very straightforward. Okay, question 8. When entering a zoo, visitors are asked how many times they have previously visited. The discrete random variable n with a probability distribution shown below can be used to model the number of times each visitor has previously visited. Given that a visitor has previously visited the zoo, that means your n value has to be greater than or equal to 1. Okay, you can't have n equals to 0 for the previous time. What is the probability that they have previously visited more than once? So this is asking you to find the probability of n greater than or equal to 2, given n greater than or equal to 1. And I mean, if you count the probabilities for n greater than or equal to 2, you've got 0.25, 0.15, and 0.05. Altogether, you should be able to get 0.45. And 0.3 plus 0.45 will give you 0.75, which covers everything excluding this case for your condition sample space, okay? And if you do a quick calculation here, I suppose you could write it like 0.05 times 9 divided by 0.05 times 15, cancel them out, and cancel by 3, you get a 3 out of 5. Okay, so the answer is 0.6, 0.6. Okay, now question 9. Let f of x equals to 3x squared minus 2ax plus 6, where a is a real constant. The set of values of a such that f of x greater than 0 for all x belongs to R. Okay, so this is a quadratic function because the leading coefficient is 3. It's concave up, positive parabola. Now for this positive parabola, you probably need to make sure the turning point HK must lie above the x-axis. And this is the y value of your turning point, must be positive. Okay? So with your CAS calculator, you could either find the derivative and sub in x to get a y and make this function greater than 0, or you just use the complete the square button. In this case, I'm going to say complete square, 3x squared minus 8 times x plus 6, x. So you should be able to get something along this line. And just be mindful, when you are dealing with the turning point here, this whole thing with the minus sign here should be your y value for the turning point. And you just need to solve the y value of the turning point greater than 0 for a. That's an interesting one. So you actually get, oh, I think I mistyped something. Yep, I missed the 2 here. That makes much more sense. That's why I didn't get any answer matched at the first place. So just make this greater than 0. Okay, much better. So it's between -3 root 2 to 3 root 2. Option D is the correct answer. Okay. All right. That is your question 9. And we are getting close to completing the multi-choice questions. Question 10. We've got a graph here. Looks like a trapezium shape. We would like to find the value of k such that this function f of x is a probability density function. Pretty much, this is your upper base, 2k. This is your lower base, 4. You've got a k here as your height. So I just need to make sure the area of the trapezium here is 1. So it's a probability density function. And you should be able to get a 1/2 times k times 2k plus 4 equals to 1. And you may want to cancel the 2 here. So you should get a k squared plus 2k equals to 1. And the k squared plus 2k plus 1 equals to 2. To complete the square, you can get a k plus 1 squared equals to 2. Therefore, k plus 1 is plus or minus root 2. And that gives you k equals to plus or minus root 2 minus 1. But based on the graph here, k is greater than 0 because it's on the right-hand side of the y-axis. And kk is in the first quadrant. Therefore, k should equal to root 2 minus 1 only. Option A is the correct answer. All right, so that's question 10, and we can look at the question 11. Question 11. In a certain location, the number of hours h of daylight per day is modeled by h of t equals to this cosine function. This is an interesting choice because now we are just taking t equals to 1, 2, 3, 4, ... And during 1 year of 365 days until 365. So my domain restriction is actually, a discrete number set rather than a continuous number set. And we would love to see there are at least 11 hours of daylight. This means I need to solve an inequality. H of t is greater than or equal to 11. What you can actually do is we'll have to sketch this function and first treat my domain like from 0 to 365 because we are talking about during 1 year of 365 days. So this is what I'm going to do. Before I do that, I probably need to change the Windows setting. Let's say we're talking about 0 to 365. And X scale, I don't really care. Let's sort it out later. Now for the Y minimum and the Y maximum, you probably need to use 12 minus 3 to 12 plus 3 between 9 and 15. So maybe try 8 and 16 and 3 or 2 actually. Doesn't really matter. Now I can just type in 12 minus 3 cosine 2 pi times t minus 175 divided by 365. Actually, that was x rather than t because CAS calculator, when you are plotting anything as a graph, it only recognizes x. So there we go. We have this function here. And we could also plot another horizontal line 11. And let's do an analyze graph. Find the intersection between the function and the horizontal line. So then we have to be very careful when we are rounding things down or rounding things up. We have to make some inference based on the context, because we would like the number of daylight hours, which is the y value, to be greater than or equal to 11. But technically, you can only take whole number days. For example, I couldn't have 103.49 something days. So I couldn't round this down, round this up to 104. I have to round it backwards to 103, okay, for this point. And also, if I take 246, that's also, not very not very true based on the requirement. We have to start with, for the next section, we have to use 247, okay, until 365. So that is like, okay, we need to use 103, actually 1 to 103, and eventually 247 to 365 to count the total number of days. This is one possible method. 103, right? You could actually use this command. I haven't been using this command for a while. In the past, I taught year 11 specialist maths. This is called a sequence command. So let's call it an x with a variable x. And we are going from 1 to 103. We can't take 104, okay? That will generate the number of days, day numbers from day 1 to day 103. And we can use this command, count this output. So we have 103 days. Now we can repeat the same process. Let's say for the other domain restriction, let's say we are going from 247 to 365. 247 inclusive to 365. And then we can count the rest number of days. So we've got 119. Eventually, we add these two numbers up. And you should be able to get a 222 days. This question is indeed a bit tricky. You have to be very careful in rounding. Also, you have to be very careful in finding the total number of days, because you get lost. You lost your count with a larger number, okay? So I believe the question should be having the correct answer, E. And next one. Let's see what happens with the next one. Okay, question 12 is another technology question. You would like to estimate the x-intercept of this slightly more complicated function using Newton's method. All right, initial estimate is x naught equals to 0. This is your f of x. Remember, your Newton's method is like xn plus 1 equals to xn minus f of xn divided by the derivative at xn, okay? And this is how we could create an iterative function. Let's say my iterative function is nx equals to x minus my defined f of x, and then dfx means the derivative function. We would like to find x3. That means I need to find n of 0. So that's one iteration, that's two iterations, that's three iterations, okay? And let's just trust our CAS calculator if we do everything properly. Natural log 2x plus 1, subtracting 4 minus x to the power of 5 over 2. Yep, and then we can define df of x equals to shift minus f of x. And then we define n of x equals to x minus fraction f of x df of x. So now we can have n of 0. And we just need the decimal answer, Control Enter. This is 1.47512, which is rounded to 1.4752, correct to 4 decimal places. So option C is your correct answer. All right. And let's move on and look at question 13. Question 13, suppose we have two continuous functions, f and g, with domain R. It is known that gx is less than 0 for all x, and f of x, f dash of x is gx. So I suppose if we anti-derive g of x, we should be able to get f of x at c, okay? Given that f minus 1 is 2 and f2 is minus 1, what is the area enclosed by the graph of G, the x-axis, and the lines x equals to minus 1 and x equals to 2? Okay, so first thing is we need to draw a diagram and visualize what happens. Let's say this is minus 1, this is 1, this is 2. An arbitrary function, let's say this is your y equals to g of x. The reason why I draw it below the x-axis is because we have g of x less than 0 for all x. Now, based on this observation, you will see the area under the curve is actually a negative region, okay, for this bit. So what you have is this chunk of region. I shaded in raspberry color. And the actual area, bear with me, should equal to negative integral from minus 1 to 2, negative 1 to 2, g of x dx. And based on this calculation, because we have put a negative in front of the integral, we can swap the order. Okay, once we swap the order, anti-deriving g gives me f. This time is from 2 to minus 1. Therefore, you should be able to get f minus 1 subtracting f of 2. And that gives me f minus 1 is 2, minus f2 is minus 1. And that gives me 3 square units. So option D is the correct answer, okay? A very smart question. Question 14, okay, pseudocode. Oh, right. Parts of the graph of the two functions f of x equals to x and gx equals to cos x are shown below, where x is measured in radians. So we've got a pseudocode below. Define intersection x naught, x1. X naught is assigned to x while loop as long as my x value, whatever I assigned previously, is less than the right endpoint. Here is a condition. If the difference between cosine x and x value for whatever x I assigned currently is between minus 0.01 and 0.01, then we return x. And if. And then you have this thing here. That's something you keep the iteration going, okay, within the while loop. And when I have the if condition violated, I probably could get something like a no intersection found or whatsoever. During the exam time condition, it's not a very good idea to program it, but let's just try to program this one. Okay, now I switched back to my TI Inspire. What I could do is I insert a program editor and I've create a new one. Let's say intersect. Doesn't really matter. We can set it like either a program or a function. Because I only use this once, I wouldn't give any other library access. So now for this function, let's see what I need to do. Firstly, I probably need to get a local x, x0, x1, something like that. And this is x0, x1. Let's press Control B. And this first thing is I will assign x0 to x. And I put a while loop here. X is less than x1 if minus 0.01 less than cosine of x minus x less than 0.01. Display x. Yeah, probably do I need an AND if? Actually, I don't really need an AND if. This is just an if condition here, and let's do x plus 0.01 is assigned to the next x. But I do need to AND while, I suppose, and return and the display. No intersection found. Something along this line. Okay. Now, the best way to test if our program works is to insert another calculator page and try the intersect program. This time, the question gave us intersect 0.6, 0.8. So 0.6, comma, 0.8. Press Control Enter. Okay. So the output is 0.74, which means my best estimate is 0.74, option D. To give you a better may not be a better explanation, but this is what I comprehend. This is what I'm thinking. If you look at the while loop, just look at the while loop. This is a necessary condition. Like you have to make sure after a certain number of iterations, if you can maintain the while loop going on, you have to make sure whatever value x you assigned before, it lies within this domain restriction. Let's say I've got a cosine x minus x given x equals to 0.7. This does not lie between plus or minus 0.01. And if you try 0.75, well, this one also goes, beyond the lower limit. If you try 0.74, well, this is a good one because this value gives me the difference between within 0.01 plus or minus, okay? If you try this one is also outside, outside the region. So the key, if you really don't want to test out the whole question by writing your own program, you probably just look at the if condition here and go through each option, okay? So that is my interpretation to the question. You may come up with a better method than I have here, okay? So let's just look at the other questions. The question 14, in my opinion, option D. And this is strange because this is the second question amongst the 20 multi-choice questions where we need to use a discrete number of values for analysis. So now I've got all these functions. C of n is 0.5 n squared minus 37.5 n plus 1900 plus 1250 divided by n. And I would like to find the minimum cost. Looks like this is another calculator or calculus question. So if you look at this graph with me, Well, I probably would drag this across and plot this function. But this time I need to use x. Doesn't look very beautiful. Let's just try to use a larger value. Let's say 2000. 2000 not even enough. Let's say 5000. And I think this number is also too small. Let's try 100. Looks much better. Okay. So what I really care is this branch of the function. It does have two branches, but the only branch I'm looking at will be the right-hand side branch. And I want to locate the minimum turning point for the minimum cost. Now, 38.35 something. Because the question says n, in this case, my x over the graph here, must be z plus whole numbers. I cannot just take a 38.3499, etc. to attain the technical minimum. I will have to make some rounding here. Let's say the nearest two whole numbers are going to be 38 or 39. So what I'm doing here is I make a comparison. I make a reasonable comparison here by splitting the page side by side. And I've defined the function, or actually I've sketched the function as f5 of x. I'm going to say f5 of 38, Control Enter. This is the cost. And I can also evaluate 39, f5 39 here. Comparatively speaking, which value gives me the smallest or smaller cost? It's this value 38, giving me the lowest, feasibly lowest cost, $1,229.89. So option D is going to be my minimum cost per item, okay? I think option E there should be some distractor, okay? Because you can technically take 39. It has a slightly larger cost. I would like the smallest cost, okay? So that's question 15. Having said that, question 15 is also, some sort of a different question. It's not difficult. It just looks different. Question 60. The values for two continuous functions, f and g, and their derivatives are given in the table below. So I would like to find the value of a derivative. What does this derivative mean? Well, this is a composite function. It's not a product function, okay? GOF. So what I'm trying to find is when y equals to g of f of x, my dy dx is the derivative of the inner function f dash times, this time we are really multiplying two things out, g dash of f, the derivative of the outer, okay? So at x equals to 0, your dy dx is just f dash of 0 times g dash of f of 0. So for the f dash of 0, let's say it's here, it's -1 times g dash of f of 0. F of 0 is 2. So put 2 here. Now, because the 2 also goes into g dash, then you can just look at g dash of 2. G dash of 2 gives you 3. So it's -1 times 3, and that's -3. Okay? Option A. Well, this sort of table and the derivative evaluation question is getting more and more popular. So just be aware of this sort of question, okay? Make sure you apply your product rule, quotient rule, or chain rule properly, and then identify the values cautiously, okay? Question 17. Suppose that for three events, A, B, and C, probability A given B is 1, and the probability C given B equals to probability C. Which one of the following statement about A, B, C must be true? Well, firstly, whenever you see this sort of statement, you will conclude B and C are independent of each other. Okay, so B and C are independent events. This is definitely correct. And the next thing I would like to see is whether or not B is a subset of A. Well, when we have this probability statement, probability A given B equals to 1, that is like probability of A intersecting B divided by probability B equals to 1. The only possibilities for such thing to be valid is when you have probability of A intersecting B equals to probability of B, something along this line, okay? That means, okay, if you have an A outside and a B inside, no wonder you have this conditional probability equals to 1 because B is totally fully within A. And therefore, when you take the intersection between them, you only filtrate whatever in the middle. Okay, that's why it has to be equal to 1. Okay, so B must be a subset of A. Or technically speaking, in the extreme case, is B totally equal to A. Okay, for the two sets to have the same potential, or whatever it is, same the same sample space whatsoever, okay? And the other options, probability A equals to 1, probability A is not equal to 1. Well, these two are contradicting statement. I'm not going to choose that, okay? And for C is a subset of B. I question that because I have a more apparent conclusion. B and C are independent, okay? Option E is impossible. Okay. Now, if you look at the rest 3 questions, they're supposed to be challenging. Question 18. F of x equals to cosine ax plus pi over 6. A is greater than 0. And there is a unique solution to f of x equals to 1 and a unique solution to f of x equals to negative 1. We would like to find the minimum possible value of A. And just notice in detail, the question didn't have much description, but you have to take care of all details, such as domain restriction. And all the numbers here, all these values here, like A is a multiple of 1/12, okay? So you probably would guessed what I'm going to do in a moment using a slider. And I will create a graph. Let's say cosine of A1 times x plus pi over 6. Create a slider. I will deal with the slider settings later. But let me just do a couple of settings. Let's say for 1, x between 0 and 2 pi. X scale, well, whatever it is. Let's just try pi over 6 whatsoever. I don't need -6 to 6. I just need -2 to 2 because I need to plot two horizontal lines, 1 and -1, okay? Remember, the provided A values are multiples of 1/12, and your A values must be positive. You need to click into your slider here. As long as you see it's blue now, press Control menu. That is like a right click, and you can select the drag down menu settings. Go to the step size stuff. Make a 1 out of 12 here, 1/12. You actually start with 0. Don't worry about the decimal approximation. It's just automatically adjusting the values, and press OK. Now you can see how it works. This means A equals to 0, okay? So you can see when A equals to 0, it doesn't give you, a cosine function. It's just a horizontal line, which is no good. What I'm going to do is I start with 1/12, no intersection at all. 2/12, 3/12, 4/12, 5/12. So you can see when it's 5/12, which is roughly 0.417, blah, blah, blah. It will intersect x equals to 2 pi, y equals to -1, but there is no intersection between the graph and 1. Therefore, I have to push this A value and make it bigger. So if I push that to 0.5, well, it's still just intersecting the bottom line, but not the top line, y equals to 1. So I have to push. Remember now it's 6/12, 7/12, 8/12, 9/12, 10/12. Almost there. 11/12, I suppose. Because now you can see, okay, a unique solution to f of x equals to 1. Only one intersection. You don't have any intersection here. And also you've got, this thing here. Okay? So A equals to 11/12. That is the minimum possible value of A for the cosine graph to intersect the top line ones and the bottom line ones, okay? And just doing that, you can see, okay, now you can observe other patterns. For example, if you push this value larger, okay, 13/12. Well, that is one intercept. Well, that is another intersection. Once you push A value up to, let's say, 1.42 something, you can see, yep, there is one intersection here, but also two intersections along the bottom line, okay? So this sort of systematic variations on your parameters, this is an essential skill to tackle higher order thinking questions or more challenging questions involving sliders, okay? Let's just look at, next two questions. And you do need to come up with some out of the thinking boxes method to tackle these sort of questions, okay? Question 19. Let f be a continuous and differentiable function over R. Part of the graph f is shown below. The stationary points are at -1 and 3. The downside of the question is we don't have any specific explicit rule for the plotted function here, but I could guess this is just a, like a cubic whatsoever. But there will be time, it will be time consuming to guess and make some regression on the rule of this curve. The question actually wanted you to find the solution to the inequality. X squared minus x minus 2 times f dash of x is greater than 0. So where is f dash of x greater than 0? And I don't know, but what I can do here is first I will locate the turning points. This is at -1. This is at 3, okay? And the next thing is, because before x equals to -1, the graph is decreasing, I should be able to get, part of the derivative graph here, and between -1 to 3. That's something above the x-axis, part of the curve. And then after x equals to 3, it's decreasing again, so negative gradient. So this is what I'm thinking. The graph of the derivative function, y equals to f dash of x, is in the form, let's say, some a times x plus 1 and x minus 3. And this is looks like it's a negative quadratic. So I should be able to make it, let's say, minus something, okay? Let's just make a -1, assume it's a -1. Doesn't really matter, because eventually we just need the positivities or negativities correct for the inequality we want to solve. So let's just use an x plus 1, 3 minus x, okay? As long as you get a correct order or correct signs in front of the factorized form, you should be fine. Then you just need to deal with x squared minus x minus 2 and x plus 1, 3 minus x greater than 0. Maybe you want to use your CAS calculator with this one. Notice that the reason why I put a negative here is because it looks like a negative parabola. But it doesn't matter what specific value is here, because eventually we can just divide things out for the inequality. And I just push the negative sign into the second bracket and make the equation solving or inequation solving more obvious, okay? So what I'm going to do is solve this inequation. We've got x squared minus x minus 2 times x plus 1 times 3 minus x greater than 0 for x. It's between 2 and 3, okay? Between 2 and 3. So option C is correct. All right. This is actually a multifaceted question. It requires you to use at least 4 skills. So let's have a look at the last one. Question 20. f of x is x squared 1 minus x squared, a quartic. G of x is a translation, but it's restricted between 0 and 1. A translation of f, but restricted. Find all real values of a such that g naught is the absolute maximum value of g. Right. So quite a bit to analyze, but if I look at the graph of f of x, x squared 1 minus x squared. So I suppose x squared 1 minus x, 1 plus x. Maybe it's something like let's do it better. This is -1, this is 1. Something like that. Okay. Could be g of naught is the absolute max value of g. Well, if you push the graph like to the right or to the left, you have this one. Move to here. Yep, that's one possibility. And you could also get this value moved to here. Something along these lines. And what else? If it's an absolute maximum at x equals to 0, there will be two cases. If it's a stationary point, maximum stationary point, you probably need g dash of 0 equals to 0. And to satisfy it's a maximum, you also need to make sure your g double dash of 0 is less than 0, if it exists, okay? For the concavity, second derivative less than 0 means part of the curve is concave down, concavity. If it's not a stationary point, but it's a maximum, well, think about the shape of the graph. You have to make sure, let's say, let's say if this is x equals to 0 and this is x equals to 1, you could have, let's say, the two maximums level with each other, okay? So that case is like g of 0 equal to g of 1, or you probably could get the graph, let's say like this. You always make sure your g of 0 is greater than g of 1, something along these lines, okay? And if it's really a maximum stationary point, and if I look at a gradient, sometimes it could be a flat point at x equals to 0. Sometimes it could be steeper. Then at x equals to 0, the gradient is 0 or gradient is less than 0. So come back with the first condition. G dash of 0 is less than or equal to 0 to actually cover some non-stationary point cases, all right? So you could get g dash of x less than 0, etc. So all I need to use is like this one, and maybe combine them together, g of 0 greater than or equal to g of 1, okay? So this is called a maximum value on the left endpoint. Okay, using a slider could be a bit painful, but yes, you could use a slider. Let's just define f of x equals to x squared times 1 minus x squared. Define g of x. G of x equals to f of x minus a. Define dg of x equals to derivative of g. Define second derivative ddg equals to second derivative g of x. Okay, I think I've done all the preparation works. And let's see how many equations I need to solve. Solve, firstly, dg of 0 less than or equal to 0. Secondly, I should be able to get a ddg of 0. This time we have to make it less than 0, not equal to, because we don't count as point, a stationary point of inflection. There's no stationary point of inflection in this case. Then g naught greater than or equal to g of 1. And all I would need to find is like this a. So let's see. Okay, so a is between half and a root 2 over 2, or a is less than or equal to minus root 2 over 2. So browsing through the options, I would choose just option E, okay? Option E. Of course, you can double check what you have here. Let's say, let's just do put this 0, put this 1, and f of x minus a1, etc. Actually, let's just use a K1, okay, rather than A1. Create a slider for K1. Oh, you can see the graph is a bit flat. Maybe I should just use a 2 here and a -2 here, okay? Something like that. Settings. Let's try. Click into that. -1 over square root of 2. See? When the A value here is -1 over root 2, this is an absolute maximum. And I could make the step size, let's say 0.01. If K value is less than that, can you observe what happens here? At this point, it can have a negative gradient, downwards trend, okay? And for A equals to -1 over root 2, it could be a half turning point, the gradient is 0. Now if you move on with 0.5 here, see? The left endpoint and right endpoint could be equal to each other in the y values, okay? Once you start to increase your A value, this bit and this bit, this one starts to be higher than the right endpoint until you choose 1 over square root of 2. This one is also, a stationary point maximum, okay? But if K value is, is larger, you can see this turning point shifts to the right, okay? And that's also a possible approach to observe a range of values, because you can see all the options contains something like a plus or minus root 2 and also plus or minus half. It's very easy to just compare the trends against these critical commonly appearing values, okay? All right. I will include my walkthrough to the extended response question in another video.